Hello everyone. Today we are going to study the next topic of the logic circuit, that is shift registers. So in this topic we have to see about the shift register introduction, that is the definition of a shift register and how it is going to be created using the gates. Next, types of shift register: SISO, serial in serial out shift register; SIPO, serial in parallel out shift register; serial in serial out shift register; then parallel in parallel out shift register. At the last, applications of shift register. So let's see what is the shift register. We know flip-flop is a single bit storage device. If you want to store more than one bit, then we have to use multiple flip-flops. So that is the first point. The flip-flop can be used to store a single bit of binary data. However, in order to store multiple bits of data, we need multiple flip-flop. When we connect n flip-flop in an order, we can store n bits of data. Therefore, we can store the n number of bits using n flip-flop. Then what is the register? So register is a device where we can store this type of storage content, that is n bits of data. It consists of group of flip-flops connected in a series and make a useful storage device with the multiple bits of data. So that is register. So next is the shift register. Shift register is nothing but it is like a register where we can transfer the stored data from one flip-flop to other flip-flop. So this is about the introduction of the shift register. Next is the types of shift register. So here we are having the way where the flip-flop is going to connect. According to this, we are going to categorize the shift register. The first one is SISO, next is SIPO, then PISO, then PIPO. Nothing but serial in, serial out, serial in, parallel out, parallel in, serial out, parallel in, parallel out. So this is about the types of shift registers. So let's see the first one, serial in, serial out shift register. Serial in, serial out shift register means it will take serial input and produces the serial output. So this is called SISO shift register. So this is the block diagram of 3-bit SISO shift register. That means it will store 3 bit and it will going to shift from one flip-flop to other flip-flop. So now let's see the figure. Here we are going to use 3D flip-flop where it will going to store a single bit for every clock pulse. Second one, this flip-flop is a synchronous one. That means it will going to operate on the basis of the clock. Next, for every input with the clock, the content is stored on the D flip-flop. For next clock, the content is going to shift nothing but from here to here. For next clock, from here to here. Like this, the content will be shift. Let's see how the content is going to shift from one flip-flop to other flip-flop. Before going to the execution of how it is going to shift, so let's see the D flip-flop, that is a content of the particular D flip-flop. So when the input is 1, the output is 1. When the input is 0, then the output is 0. That means it will going to set and reset. So let's start with the sequence. So that is 1 0 1. How this input is going to get at the output side. Clear? First we have to take the first input by applying the first clock. Now the input for the D flip-flop is 1. Then the output is 1. Right? At the same time, the clock is applied here and the clock is applied here. So there is no change in the D flip-flop. So I explain once again. The first input is 1. Okay. The clock is going to apply at the same time. For this flip-flop, there is an input 1 and clock. So the D consists of the storage 1. Okay. But here there is no input. For third D flip-flop, there is no input. So there is no content stored on these two flip-flops. So nothing but there is no storage. Okay. So this is the first bit stored in the first flip-flop. So next, the second input is 0. Again the clock pulse is applied at the same time for the all the three flip-flop. So now the 1 will shift here, that is 1 here. Now here it is 0 and here it is 1. So 0 and clock will going to reset this from 1 to 0. 1 and clock for the second flip-flop, it will going to set. Here there is no input, so there is no content stored on the particular third flip-flop. So next, in the first flip-flop, in the previous, the content is stored like this. Then the output, here it is 0 and here it is 1. So next, the input is 1. The clock will apply. Now for the third flip-flop, the input 1 and clock, it will going to set and the output is 1. For second flip-flop, the input is 0 and clock, the set content is reset. Then for the first flip-flop, the input is 1, the content is 0, it will going to reset. So like this it will going to store the data. See here, the first bit outputted is 1. So let's see for the next clock. For the next clock, there is no input here because there is no fourth bit. So clock is applied. Before the clock applied, the output of the second flip-flop is 0 and the first flip-flop is 1. So now the fourth clock will going to apply. Fourth input is not there. So at a time, all the clock will going to apply on this D flip-flop. So now at the last flip-flop, that is third flip-flop, so input is 0 and clock applied. So set is going to be reset. Then for the second flip-flop, the input is 1 and clock applied. So the reset is going to set. So here for the first flip-flop, there is no input, so here it will go with the content that is not shifted. So this is not shifted. Now check the output what it is having now. The output we get here is 0. For this it is 1. Here no output of the first flip-flop. So next, the fifth input is given. There is no fifth input. The clock is applied. Now for the third flip-flop, the input is 1 and the clock is applied. Then the content stored in the flip-flop is set. For the second flip-flop, there is no input, only clock. So there is no content, that is nothing but no change in the flip-flop. And the previous first one, again already it is defined, there is no content in the flip-flop. So now check what is the output for the present flip-flop condition. So that is for 1 it is, the output is 1. For 1 the output is 1. Nothing but for input 1 the output is 1. So by this we will get the as it is input at the output in a serial manner. So that is serial input. So first we taken the first input 1, we got the 1. Second input 0, we got the 0. Third is 1 and third is 1. So like this we are going to get serial in, serial out shift register. We will get the input at the input side same as the content at the last. By this it's conclude that the serial input will going to give you the serial output. So whatever you are going to give as an input, that will be going to get at the output side in a serial manner. So you have to give serially the input and we will get the serially output at the output side. So take a look whatever we studied in the block diagram. So it consists of 3 D flip-flop which are cascaded. That means output of the one flip-flop is connected as the input of the next flip-flop. Then all these flip-flops are synchronous. That means it will going to use the clock, that is same clock for all the flip-flop. In this shift register we can send the bits serially from input of the leftmost D flip-flop. For positive edge it will going to trigger and shift the content from one stage to next. So we can receive the bit serially from the output of the right side of the D flip-flop. Hence this output is also called as a serial output. So this is about serial in, serial out shift register. The second type of shift register is serial in, parallel out shift register. So this is the same, but here the output will going to get in a parallel manner. So we are going to wait all the D flip-flop should be in a particular condition, that is set or reset. After that we are going to extract the output of the all the flip-flop. So this is the block diagram. 3-bit SISO, nothing but 3-bit SIPO. So this one is SIPO, that is SIPO. Shift register, where we can get the serial parallel output from the serial input. So let's see how it is going to work. So same example 101. The first input is applied and the clock at the same time. The point for this block diagram is same. We are going to use 3D flip-flop. It is a synchronous one, nothing but it will going to apply the clock to work the flip-flop to be stored the data, or it will going to shift the data. Then according to the condition of the D flip-flop, the input is 1, the clock is applied. So for the third D flip-flop there is no input, so no operation in the third. Then for second there is no input, so no operation in the second. For the first there is an input, that is 1 and clock, so the first flip-flop is going to set and give rise the output to 1. So now for the second clock pulse, the second input is going to extract, the clock is applied. The third flip-flop there is no input, so no set or reset. For second flip-flop the input is 1, so the clock is going to apply. According to this, the flip-flop is going to set and give rise the output as 1. For first flip-flop the input is 0, the set content is back to reset, the output is also reset. So now this is the condition for the second clock. So now we have to apply the third clock for the third input. So this is the third clock. One second. So we are going to apply the third clock. So this is the third clock condition. So third input, third clock is going to apply. For the third flip-flop the input is there, so the D flip-flop is going to set. For the second one, because of the input is 0, the flip-flop is reset, giving the output as 0. Here it is 1. So next for the first flip-flop the input is 1, the internally the content is already 0, so it will going to set, give rise to the output as 1. So after this, at the same time the output is going to extracted here now. So this one 1 and this one 0 and this one as 1. So therefore 1 0 1. So like this we are going to get the series of input as a parallel output. So here the main concept is you have to give the input serially and wait all the flip-flop to be worked with the storage content. Then you have to extract all the outputs at the same time. So this is the serial in parallel out shift register. So let's see what is the content we focused on that diagram. The first is 3 D flip-flop cascaded and connected in a series manner. That is, the output of the one flip-flop is taken as input for the next flip-flop. All these flip-flop are synchronous, that the same clock is going to apply. Then the shift register are connected in serially and we are going to give the input in the manner of the leftmost D flip-flop. For every positive edge trigger of the clock, the data is shift from one stage to next stage. Here in this case we are going to extract all the outputs at the same time to get the parallel output. So we will wait for all the bits to be shifted from one flip-flop to another and all the flip-flop is in a condition of a storage. Then we are going to extract the output of those shift register or a flip-flop. So this completes the SIPO, that is serial in parallel out. So next one is the parallel in serial out. So here we are going to give the input in a parallel manner and produce the output in a serial one. So it is called as parallel in serial out shift register. So let's see the block diagram. So this is the block diagram of piezo. So here we are going to use 4D flip-flop. This one. Then we are going to use the AND gate and OR gate and 4 inputs in a parallel manner and 1 output in a serial condition. Next is we are going to apply the clock at the same time. So this is the figure explanation. So here we are having two operations, so that is the shift and load. So before going to shift the data, we have to load the data first. So for load, we have to operate in a complemented manner. That means if the load is equal to 1, then the complement of it is 0. That means what? This condition will going with the operation of low. Low means the particular output depend on the load condition. So let's see how it is going to work. Here it is, the load is 1. Okay, so load complement, so load complement, that is 1. That is the particular content of the load is 1, then the complement of it is 0. Okay, so that is, I repeat once again, load is equal to 1, nothing but load complement is equal to 0. Clear? So now here the load complement condition is 0. That means here it is 0. Clear? The load is high is nothing but load complement is low, but the operation is load. Clear? We are going with the load operation. Load operation should be done, we have to take it as 1. If it is 1, the load bar is nothing but 0. Clear? So this is how we are going to consider here as 0. Clear? So next we see what are the output of the load. For here it is 0, here is 0, here is 0 and here is 0. Then after the complement for this, the output is 1, 1, 1 and here it is 1. So these are the outputs of after the load is applied is equal to 1. Load is applied is equal to 1, nothing but the complement of load is equal to 0. So this is the output of the load line. So next is the input, that is D0, D1, D2, D3. Take an example. Input is this one, that is 1, 0, 0, 1. So this is the input. D0 is 1, D1 is 0, D2 is 0 and D3 is 1. So let's see how the operation is going to done now. For the gate 1, the input line, see the input line D0 and 1, right? Only see the input line D0 and 1. So for 1, 1, the output of G1 is 1. So the flip-flop is set to 1, the output is 1. For G5, the input is 1, 0, so output is 0. For G2, the input is 1, 0, so the output is 0. The output of the OR is 0, so the flip-flop is 0. Then the output of that flip-flop is 0. For G6, the input is 0, so output is 0. For G3, the input is 1, 0, the output is 0. For OR it is 0, the flip-flop is 0, the output is 0. The G7 input is 0, 0, the output is 0. For G4, the input is 1, 1, so the output is 1. For OR of these, that is 0, 1 is 1, so flip-flop is 1 and the output is 1. So this is how the input, this one, is loaded here. So let's see the next operation, that is shift. So these are the considered content for the next shift. So now the shift is equal to 1. Now the shift line output here is 1, 1, 1, 1. After the NOT gate it is 0, 0, 0 and here it is 0. So now see when the clock is applied what the content is going on. The input of the G1 is 1, 0, so output is 0. The set content is going to become reset. Then for G5, sorry here, so one thing you have to remember, that is when load is applied the clock is applied, when shift is applied there is no clock. Okay, so if there is no clock the flip-flop output we will not get. Clear? So just it will going to shift. So when I get the gate 1 output as 0, the flip-flop stores it but it will not give the output. Okay, so the previous output is considered, that is 1. For G5 the input is 1, 1, so output is 1. So output is 1. For G2 it is 0, so OR of it nothing but 1. So here the content for G6 0, 1 is nothing but 0. here it is 0 for G3, so 0, so output is 0, same. For here it is 0 1, the output is 0, 0 1 for G4, the output is 0, both the input are 0, so OR is 0, here it is 0. So by this we will get the first bit as a serial one, so that is this one. So we got the first bit, that is this one. So I repeat the point, the important point, that is the PISO consists of two operations. So it consists of two operations. So that is two operation, that is load and shift. Okay, so this is the one cycle it is going to operate. That means for load it will take clock, for shift it will not take clock. So if there is no clock, that D flip-flop will not going to give you the output. If there is a clock, then it will going to give the output. So this is the main point. So first we have to load all the parallel bits to the flip-flop. After that we have to go for shift. By this it will going to shift to get the output at the output side. So this is about the parallel in serial load shift register with the 4-bit one. So just take a look what are we studied in this. The first one we are going to use, here it is 4 D flip-flop, which is cascaded. That means out of one flip-flop is connected, output of one flip-flop is connected as an input to the next one. We are going to use synchronous one. We are going to apply the clock. In this shift register we can apply the parallel input D flip-flop by making preset unable to 1. Nothing but we have to do the loaded condition on this. So first we have to do load, then we have to go for shift. That is preset condition 1. So for every positive edge trigger clock, the content is shift from one stage to another. Nothing but before shifting we have to load. After that it will go for the particular shift. Nothing but the clock will apply on a single cycle with the start from load. Clear? So it start from load. So we can receive the bit serially from the output of the rightmost D flip-flop. Hence this output is also called as a serial output. So in this slide I didn't point about the load and shift, but when you are explaining in the examination you have to put concentrate on load and shift. So you have to write that for load all the parallel bit will going to store on the flip-flop. For the shift it is going to be shift from one flip-flop to another. Okay. The last shift register, that is parallel in parallel load shift register. So here the shift register will going to take the parallel input and produces the parallel output. So this is called as PIPO. So let's see what is the block diagram of it. So this is the block diagram. So it consists of 4 inputs, 4 D flip-flops and 4 parallel output and a clock with all the flip-flop, that is synchronous one. So let's see how it is going to work. Take an input 1001. So the clock is applied at the same time for all the flip-flop. Then the first flip-flop input is 1 and clock, so it is going to set the output is 1. Next for second it is reset, the output is 0. For third the input is 0 and clock, so it is reset, So output is 0. For the third flip-flop, the input is 1 and the clock it is set, the output is 1. So by this we will get all the input as it is at the output side. So this is about parallel input and parallel output. So it consists of 4 D flip-flops and cascaded. Synchronous one, same clock apply. All the inputs in a parallel manner without any independent of clock transition, that is there is no shift. So we will get the parallel output at the each D flip-flop. So this is about the PIPO. So last one is applications of shift registers. So shift registers are used for temporary data storage. So it is a temporary one. We can use this for data transfer and data manipulation. This serial in, serial out, parallel in, parallel out shift register are used to produce a time delay to identical for the digital circuits. The shift register, that is serial in, parallel out, can be used to convert the serial data into parallel data. Parallel in, serial out shift register used to convert the parallel data to serial data. By this conclude the shift register. So this completed the topic shift register. The remaining counter topic explained in the next video. Thank you.